Today we're going to go through the LeetCode problem 862. It's the shortest subarray with some at least k. But before we go through this problem, I want to go through another problem first. It's like a prerequisite question for this one. It's the number is 209 minimal size subarray sum. So, okay, let's go through this problem first. So for this problem, we need to find the minimum length of a contiguous subarray, which the sum is bigger than the target sum. If there isn't, we cannot find it. We just return 0 instead. So for this problem, I think it is a very classic sliding window problem, right? Sliding window basically is like a 2 pointers and stuff. So we have a 1 pointer is a start, and we have another pointer is end, and from the start and end we can get a window size of this subarray. So let's go through the first example over here. The target is 7. Okay, we go through this example. So the current sum over here now is 2, and 2 is smaller than our target sum, so we increase our window size by the end pointer. So right now it's 5, 6, 8. Okay, 8 over here is obviously bigger than our target sum 7. So we need to shrink our window size by moving our start pointer over here, right? Over here. So our current sum is 5. 5 is smaller than our okay. Before I move my start pointer, we already have a result for our window size with 4, but over here we wanna get the minimum one, so I move the start pointer. So it's 8, right? But 8 minus 2 is 6. 6 over here right now. 6 is smaller than 7, so we need to move our end pointer is 10. 10 is bigger than the 7, so we need to move our start pointer over here. So it's 7 right now, and the window size apparently is 3, is smaller than the 4, so we update the window size become 3. Okay, so over here we keep because we already find the satisfied window size, we need to move our start pointer. Okay, over here is 6. 6 is smaller than our 7, so we need to move the end pointer is 9 over here. 9 is bigger than our 7, so we need to move start. Okay, move start. We got another subarray sum is 7, so we update our result is 2. So the minimum size for the subarray sum equals to 7 is 2. We got it. But there is another problem. What if we have a negative numbers in our arrays? Can we do this problem exactly the same way like the example 1? And apparently no, we cannot do it. So let's retraverse this example. We have a negative 2 over here, and we have a target sound is 7. We start by the start pointer and end over here. We can over here we cannot get the Windows get the correct answer by the way we applied before. So let's traverse this example as a first. So first, our current sign is -2. So apparently -2 is smaller than 7. So we need to move our end pointer. Over here is 1. And our current sign is 1. 1 is still smaller than 7. We need to move the end pointer to over here. And then we current sign is 5. And 5 is not satisfying the target sound 7. But at the same time, we already traversed all the array. This means we cannot find the subarray sound is equal or bigger than 7. So for this question, we will return our result will be 0. But actually, we can have the subarray to count. We can have the subarray. The sum of the subarray can be equal to 7. That is 3 and 4, right? But if we apply the way we did before, we cannot get it the correct result. So let's wait. This is the key point of today. So let's continue our problem. So this problem is related to 862. Find the shortest subarray with sound at least key. Let's take an example over here. What's the question is it? And take a look at example 3. We have 2, -1, 2 over here. We need at least k satisfied to 3. So we need to apply all the elements in this array. And to be honest, I can't see the things from those examples. So I just made myself the example. So please take a look my example over here. So my nums is equal to I have 5 elements in my array, and my target is 167, and I already said before the previous question, if we have a negative number in our array, we cannot apply the sliding window things in this question. So for this question, what should we do? It's kind of difficult for me at the first time, to be honest. So I take a look at this answer. They said we can use a prefix sound to figure it out. So let me introduce you what is prefix sound at first. So prefix sound array is it's an array. You can take a look over here. The length of my prefix sound is one more bigger than my normal nums array. And you can take a look. The first elements, you can see over here, they have a plus sign in the black arrow, and the green arrow is the result. Is the result of the this one plus this one. So in my prefix sum, starting from the 1, the index 1 is 84, and 84 plus the Negative 37 is 47 over here. So this value is the sum of this value. And this value 79 is the sum of the previous three elements value. And you can see over here, we got the prefix sum. So what should we do with the prefix sum array? So imagine it. We wanna find the subarray with sum at least k. And think about it in a mathematical way. We can represent this thinking by this formula, right? The prefix sum as a sum position y minus as a sum position x should be bigger or equal than the k. Right. So think about it in a mathematical way. If we want our k, the result k is much bigger, which means our prefix sum x position should be much smaller, because this value it's not gonna be it cannot be changed, right? It's all cannot be changed, because this value will definitely not change. So if we want to get the k bigger, that means we need to stay our prefix sum smaller, always smaller. So over here, I'm thinking about it. I want to traverse my Python array. First, right? So I will use a queue to store the index of my Python array. And at the same time, the sum of the index should be increasing, should be always increasing. So I will explain later. I don't have to type it out. Okay. So over here we have a sum. Let's traverse the example first. I have a queue, and I will push the first element of my Python. The index is 0, and the value is also 0, and push the second one. Index is 1, value is 84. Okay, 84 over here. And the third one, the index is 2, but the Python is 47. Okay, hold on, wait a second. I just said I wanna store the index of my Python in the queue, but I only store the Python is in an increased way, right? Why I wanna store like that way? So think about it. I already said these things is like a position x. Position x I stored in my queue. If my position x, the place on the value x, is bigger, over here I don't want to push the second value in my queue, which is index is 2, value is 47, because I still processing. Right, I'm still processing it. So think about it. The 84 is bigger than my 47 over here. Okay, over here I have a two value, one value is 40. 84, another value is 47. If we want our k become much bigger, which means we need to keep our place on x much smaller, right? So we don't want a 40, we don't want an 84 over here. Instead, we want a 47. So, which means we need to pop it out from my queue, right? Over here. I will delete it. And then my queue will become 0, index value is 0. And index is 2, my value is 47. And we keep adding because the 47 minus 0 is not bigger than the 167. So we keep add it to my queue is 79. So sorry, I'm not very sensitive about number stuff. And this is 4 index number is 4, and we got a 119. And the index number is 5. We got the 214. We got 214 over here, and you can see 214 is definitely bigger than our k. And over here we can shrink our window size now, right? Because at this moment we already can get our result. The result is 5. But at the same time, we can shrink our window size because 0 is not. You know what I mean, right? So we shrink our window size, become 4, and we can shrink it again. 214 minus 47. What is it? It should be 177, right? 177. 2 minus 47 is equal to 177, so it's much bigger than our 167, so we can pop it out. So our queue, queue becomes this same stuff, and 177 minus 79 is definitely smaller than our 167, sorry. So right over here, my result will become 3. So the 3 is the minimum, not minimum, you can say minimum, is the shortest Subarray with some at least k. So this is the problem for today, and the problem have several key points. One key point stuff, we push the value, right? The index, the value of person in our queue is in one direction. What direction? In increase directions way to push it into our queue. And another point is that it's not the normal queue we used before. As you can see, we can access the queue from two directions, the front side and the end side. So for there are special data structure we can do. This stuff is like a DQ. It's named DQ. So basically it's a queue, but it's a kind of special. We can access the elements from the front side and from the end side, so we can get the time complexity by O(n) stuff in linear time. Right, and another point is the Python concept. And that's it, and this is the question for today. And there have several similar questions for this one. One of my favorite is 907. This question is very interesting. You can try it. So this is the question today. That's it. Bye.